Alrighty.
Okay. Well, let's see. So did you do part one or no?
A little bit. I looked at it a bit. So,
Yeah. Question one. What's the
Hey guys,
difference between...
hey Maria,
Hey.
did you guys start already?
we're just
Just
starting.
barely.
Oh, like you're doing the first question?
Yeah.
Yeah.
Okay, I'm
Okay.
ready.
Okay, so question one was difference between match pair data and independent samples was just there's no pairing between your group one and your group two on independent. So it's not going to be the same people.
That makes sense. Yeah.
Whereas
Yeah.
in paired it was like pre-test, post-test.
Right.
Yeah, I did like one group doesn't depend on the other group.
Yeah.
Then I have the chart in front of me. So,
Okay. So the chart, um, honestly, so like you have your hypothesis test names. Like, do you have her answer key one in front of you?
yeah.
Okay,
Yeah.
the requirements for the test is SRS and normal distribution for all of them.
Uh-huh.
And then the name of the distribution test is a t-distribution for all of them, except for the one that she gives us.
There's an unknown.
Where was she getting this information from? I couldn't like I didn't fill it out because I didn't like I looked at the answer key and it all made sense, but I didn't know where she was getting where I was supposed to fill it out from.
It's just drawn off the past three lessons.
I, Oh, so it's just like okay. Okay.
Yeah.
Makes sense then.
So
Okay.
yeah, so the first test, H for one, average, and sigma unknown, that's just your one sample t-test.
Yeah,
The
okay.
next one's your paired t-test, and then the bottom column is your independent samples t-test, which that's the new one.
Okay. I thought there was like this category within this chapter that was like I have no idea what I was thinking. I've got food poisoning. I was blaming on that.
Oh.
Yeah,
Yeah.
it's just a summary.
Okay, that makes a lot more sense because I was looking at it, I was like, this looks like everything we've been talking about, but I just don't know where she's getting it from. Like,
She she has a chart somewhere near the beginning of the class that um it ends up being like what you can use for preparing for your tests, and it has like all of the tests with blocks that you can fill out.
oh yeah, I downloaded that. I know
This
what you're
is
talking about.
this is like a little chunk of that one.
Oh, I see. Okay.
I'll probably fill that out at some point because it looks useful.
Yeah, it does. Okay, cool. All right.
Yeah, I think the chart's pretty straightforward though.
Right.
Like the stuff makes sense in it.
All right. So part two. Did you do part two already, Tim?
Yeah, I did, but I'm not in any hurry, so.
Okay. Sounds good. Um,
Awesome.
Independent samples. One of the professors in the BYU Idaho Math department collected data from students to compare the mean wages of males and female students. The students from his classes completed a survey, which he then used to analyze if there's difference in these wages. So we have to use the class survey data. I should have opened up SPSS before the thing started because my computer is so slow when we are doing the thing. So
Yeah, I'm gonna open that up in a second.
Mine's opening up right now.
Okay.
So basically, you do the same thing as last lesson, but then you make a histogram where the two graphs are side by side. Or do we not have to do that yet?
I don't even know if we have to make a histogram.
Oh, really?
But the
Okay,
research question. Wait. Okay, I have it pulled up on SDSS. The question is, what's the difference, the mean difference between males and females, right?
Yep. And so your null hypothesis would be males equals females for wages.
Right.
I just went like mu1 equals mu2, but however you want to write that.
Right.
And the alternative would be mu1 does not equal mu2.
Right.
That stuff, design the study is pretty easy.
Yeah.
It said describe the data collection procedures in
The
the
students completed a survey.
yeah, that's all it is. They surveyed their students.
Yeah.
Question 3 is where you have to use SPSS.
So,
Let's see.
Um,
Oh yeah, this is the one where they give us a bunch of data we don't need.
yeah.
Last survey?
Yeah.
Yeah, there's a lot. So
I feel like we'll probably use it again later.
So, to get the mean and
Let's see.
how do I do that? I just go to analyze, descriptive status, explore, and I enter in gender and wage?
Yeah, so wage is your test variable, gender is your grouping variable. Or whatever they call it. I gotta pull it up.
It won't let me put in gender into the dependent list.
the string variables are not allowed.
Yeah.
Yeah.
It lets you put it into the factor list.
Oh, it does? Okay.
You have to make it a factor. Anything that's not numbers can't be in the dependent list. That's how it
Okay.
works.
Okay, so I have that.
One second.
So the mean for males. Okay, I'm here now.
Oh, cool! It separated it all out for us.
Yeah.
SPSS is actually pretty easy to use.
For now.
Yeah.
For now.
I had no faith in it. I was like, I bet I'm going to do something wrong, but I didn't. Yay! Okay, cool. All right.
Cool. So I got number 3. You guys all got 3?
Yeah, your summary statistics is just your standard or your mean for each gender, your standard deviation for each gender, and the number of samples.
Yeah.
Right. Wait, what does S mean?
Wait.
Standard deviation.
That's right. Okay.
Yeah, that's what it is. Okay.
Yeah, because under total, 95 and 88.
Yeah.
Okay.
We make inferences. What type of hypothesis test is appropriate? As we are going over the independent samples,
Yeah.
Yeah.
So you think it's probably that one?
I think so. The requirements.
They are not met for this one.
Is it because it wasn't a simple random sample?
Yeah. Your sample is large enough to be normal, but it wasn't a simple random sample. But then all she does on the assignments from here on out, she doesn't say it on this one, but on like 14, she says even if it doesn't fit the requirements, solve it anyways.
Dang it.
Yeah. So we have to solve them still.
All right, and then compute the test statistic. That is what we did last time.
Yeah, you can do it on SPSS.
So it's under
Analyze, compare means.
paired sample t, or one sample t-test.
No, independent sample t-test.
Oh, yeah. Oh, new one. Okay.
Yeah.
Analyze, compare means, and then paired sample, right?
No, that's what he just did. It's
Oh my
independent
gosh.
sample.
Independent sample. Okay, compare means.
And then grouping variable, the gender.
Yeah, and you have to define the groups.
So the test variable is the wage, right?
Yeah, your test variable is wage. Your grouping variable is your.
Is the gender.
Yeah. Okay, I'm trying to get it in. SPSS version 19 is really glitchy. For free version I'm using right now, stuff pops up over each other all the time.
Oh, how annoying. It's a good thing that you are fairly good at statistics anyways. I would be dying. So then I have to define the group, right, you said?
Yeah, so you just make one F and the other one M for male and female.
Okay.
Where's wage?
Does it matter if I did M first and F second, or does it not really matter?
Not as long as you know what it is.
Okay, cool. Okay. T-test. Plus or minus 1.889.
Nope.
Oh.
We use equal variances not assumed.
Oh, yeah.
It's weird.
Okay.
Will we always do that? Equal variance is not assumed?
For independent samples tests, yeah.
Okay.
Gotcha. That's tricky.
Yeah.
And then the degrees of freedom, 98.263.
Yep.
And then p-value is the 0.069.
Yep.
0.069.
And you fail to reject the null because p is greater.
Yeah.
Okay.
And then the weird English sentence thing.
My favorite part about statistics. That's interesting. A confidence level.
Where were these?
Confidence interval.
How are you calculating that?
I'm trying to remember how I did it.
Oh, SPSS. Here we go. Let's see.
That one.
Wait, it's just on that independent samples t-test. You just slide over and it says 95% confidence interval of the difference.
Did it? Let's see.
Wait, but I'm confused now because what's negative on SPSS is positive on her answer key, and vice versa.
Yeah. Mean difference. Let's see.
I got what she got.
How'd you get that? What did you do for it?
So if you look to the independent samples test, on the far right, 95% confidence interval.
Yeah.
The difference
Yeah.
lower should be negative 0.176, and the other should be 4.528.
Mine's switched though. Like it's negative.
Yeah.
Did you put female, male?
Huh?
Did you put female first?
Yes.
Maybe that's why. I put male first.
That's so annoying. Let me try. Let's see. Let me try doing that again. See if that makes a difference.
Define groups. Male.
It may, because it's like the reciprocal.
Yeah, it does. It just flips it.
Yeah.
And if she doesn't specify which way to do it, then
you could argue to get your point back, I'm sure.
yeah.
She's pretty good about that.
Yeah.
Sweet.
Yeah. And interpret the confidence interval. 0 is included, so we can't reject H naught. If 0 falls between the range of those two numbers, you fail to reject.
I concur.
And that was it. The short paragraph thing, I don't know, whatever.
Yeah. Sweet, let's do our classwork. Alrighty.
I'm going with A and B on number 3.
Hold on, I have to open it real quick.
Okay. Statistic for difference procedures.
Yeah, 3 is A and B. Are you there, Marietta?
I am, and I agree with you guys.
A statistic for hypothesis.
T-score.
T-score. An F?
Yeah,
An F statistic.
that's less than 14.
Oh, is that?
Yeah,
It's an actual thing.
yeah.
Oh. I was
F statistic is for when you have more than 2 groups.
Oh my gosh.
So
Yeah, I got a C on lesson 14's quiz, so.
two
No!
samples are independent if knowing which subjects are in group 1 tells you nothing about which subjects will be in group 2.
Yeah, I'm gonna have to go with that, but it's not always true.
Really?
Yeah, there's examples like if you're gonna do siblings, say like you're gonna sample brother sisters, they'd still
Yeah.
be independent samples because the brother doesn't affect the sister, but because you chose that brother is affecting that you chose that sister also.
Yeah.
There's a question like that on our next homework quiz.
Hmm.
This is wretched.
Just to make me mad. Dentist bills. Yay.
So, Tanner, are you glad you're not taking this class on campus?
No, I wish I would have.
Oh, really?
Yeah.
I
Everyone aces the class that takes it on campus that I know.
I know. That's my brother got like a 98 on his first test because he took it in class.
I have a friend who has 100% in the class still.
Oh my gosh. It's just I don't got time for this stuff.
Oh.
There's just stuff going on. Okay.
How do you rename? Oh. Okay, I was like, how do you rename the variables?
So the test variables, we're gonna put one in grouping variable, correct? No.
What?
What were you saying?
For the dentist's office,
Yeah.
we both put them in. For SPSS, we both put them in the test variables.
Oh, yeah.
That's what I was gonna do. I don't know though. Is it right?
There's different ways you can do it. That way should work. Level of significance of 0.1. So make sure you change that also.
Can't click OK.
Oh, because you have to have a grouping variable. Okay, what you do then is... Okay, this is going to be weird. You have to put all of the values in one column, but what you do is you have to assign Idaho Falls Group 1 and Rexburg Group 2.
Oh, okay.
Wait, what did you do?
You have to put all of the values in one column, and then you have to assign the values for Idaho Falls to Group 1 and the values for Rexburg to Group 2. So you just make another column next to it, putting 1s and 2s, basically.
Okay.
It's weird.
Yeah. Okay, so you guys did Idaho Falls numbers first?
Yeah, I did Idaho Falls as 1. I copied all the Idaho Falls in, and then the column next to it put a 1 next to all of those. And then I copied all the Rexburgs in underneath and put a 2 next to all of those.
I see. Okay.
And so then you can make that your test variable and your other column your grouping variable.
Well, I'm still a little confused. You put all your values in the first column, right? 1 to 40?
1 to 40? Oh, there is 40 of them. Yeah.
Okay.
Yeah.
And then you gotta analyze, compare means, independent samples.
Did you group them already?
No.
You're not able to do the t-test to group them. Here, I'll show you what I mean. Where's my screen share?
That'd be quick.
Let's go with this, share. Okay. So you see my columns here?
Perfect. I'm doing.
So you put a 1 right next to all of your Idaho Falls values and a 2 right next to all of your Rexburg values.
Okay.
Because then you make that column your
1s and 2s.
you make it your grouping variable.
Okay, sweet.
So group 1 is 1, group 2 is 2.
Yeah.
All right.
It's like, and as long as you know that it's Idaho Falls and Rexburg, then you're good. You can actually assign them names, but it's way faster to just do numbers.
Right. So then we do the equal variances not assumed, right?
Yeah.
So it's 37.996.
Wait, you probably did what I did. Did you change the level of significance?
I don't think so.
You gotta go in and change it
But where am I changing it?
in options under the independent samples t-tests.
What should the level of significance be?
It should be 90 because it's saying 0.1, right? Alpha is 0.1. So
Wait,
it should be 90 instead of 95.
Yeah, mine's 95.
You have to change it to 90.
Why?
Because in this specific problem, she says the level of significance of alpha equals 0.1.
Oh my gosh, that doesn't make any sense.
It's only going to change your confidence interval. It shouldn't change anything else, but...
It's okay, I'm not mad at you.
Hmm.
Alright, to 90%.
Yeah. Because your confidence interval is just 1 minus alpha is what it is.
Oh, that's so tricky. Why would she do that? If she's watching this, don't do that for the test.
How she watches this?
I doubt it.
Not all the way to the end, at least.
I know.
Yeah,
Okay,
so
it still is
37.996.
37.996.
Yeah,
I got that. Yeah.
that's what you got?
Mm-hmm.
Okay. Standard deviation.
I got 206.637.
Yes.
206.637. That statistic is negative 0.434.
Yeah.
Negative 0.434.
Yep.
Wait,
P-value
1 second. Sorry, I got lost a little bit.
P-value is lucky. 0.666.
Yeah.
Oh.
Oh, the best part about the test when we do F statistics on the next lesson is the value is always positive.
Oh, so
Awesome. So the oh, sorry.
No, you're fine.
Oh, so for number 7, it's the 206.637, and then the test statistic is negative 0.434.
Yep.
Okay. And then the p-value is 0.666.
Yeah.
That's just unlucky.
Based on that, we failed to reject the null
Right.
because it would have had to be under 0.1.
Oh, that's so tricky. Oh my gosh.
You're so used to it being 0.05, huh?
Yes. It's so annoying. This is school, not real life. They can't change stuff on us.
Suppose your alternative hypothesis. Let's see. Wait, what was our alternative hypothesis originally? Oh, it was less than.
less than you too.
Wait, then our p-value should be half.
Oh, yeah, that's true.
3.333.
Oh yeah.
I'm glad she asked that question. Or I'm like, we would have missed that. So it still failed to reject both times, but it changes our p-value at 9 to 0.333.
So then wouldn't we reject the null for 11?
No.
Or
It has to be under 0.1.
on 11, it would still fail.
Oh, yeah, because on 11 it would be 0.666.
Yeah.
Now it's looking like we got to do more values for 12 through 16. At least she went back to 95% confidence this time.
I'm
Thank
just
you.
grateful for copy and paste.
Me too.
Don't want the good old days of computers without mice where we'd have to type command prompt everything. Be fun. I think it's like 4 hours to do this assignment. Copy. So yeah, you'll just do the same thing again where you sign them 1s and 2s.
Mm-hmm.
Unless you really want to assign them Colorado and Utah, but I know I'm not.
What was that?
I was like, unless you really want to assign them Colorado and Utah.
Oh, yeah, no.
Damn.
Be sure to change your options back to 95.
That's right.
Yeah, I just closed the program
Yeah, I see.
and reopened it because it defaults it. I'm a cheater.
Number 12 is that it does not equal each other, right?
I don't know, I didn't read the actual problem. Yeah, it's not asking for less than or greater than, is it? From the original question. Doesn't seem to be.
Yeah.
It's just, do they cook dinner a different number of times?
Right. Test statistic is 0.845,
Uh-huh.
Yeah.
and then the p-value is 0.41.
0 point, yeah. Failed to reject.
Reject. And then it's negative 2.204.
Yeah. And 5.137.
Right.
Okay, I'll submit mine first today. Okay, guys, we got them all.
Woo!
I gotta go. My wife needs to be picked up from the school.
Great.
Okay.
Thanks, man.
Bye.
We're meeting at 6:30.
Yeah, 6:30.
On Monday.
Okay, sounds good. See you guys.